And hello everyone. So today we're gonna continue our investigation of our OpenFOAM boundary layer flow. So this was our last video, of course, and previously we actually found out how to increase the mesh resolution. Okay, the mesh resolution. So okay, it's one of these files. I've been doing lots of experiments, so hope you don't mind. Anyway, it should be in this one called flat plate fine. There you go. Flat plate fine.foam, and we realized that okay, pretty much it looks so similar that you still have this red patch here in the center, and we don't know what's going on. So we're going to continue our investigation on what's going on. Of course, there's one very simple solution at the end. You'll find out at the end of the video series, but this is just one example. We're going to go through the many features of IcoFoam while trying to troubleshoot this flat plate problem, so that you'll get a good understanding of what's going on. So we're going to troubleshoot in a more logical way, like as if we really don't know what's going on. So hope you stick through this video. Okay, so in the next step, we found out that since increasing mesh resolution maybe doesn't really help, it may help to actually look at what other people have done to make their file work, so to speak. So there are two links. One is called this Blasius Flow Benchmark. These are very useful links. Oops, I pasted the picture instead of the link. Blasius Flow Benchmark. And this one. Both are talking about laminar flat plate flow. And if you actually look at this mesh resolution here, look at how they set it up. Okay, I'm going to paste it here, and I'm going to use paint so I can do some illustrations. Okay, if you notice, our OpenFOAM file, usually on the left we will have an inlet here, right? We'll have an inlet. Then here we'll have zero gradient, and then we are expecting to see some kind of boundary layer flow happening, like so. Of course, that didn't work for some reason, and we are trying to figure out what that is. So if you see what people actually do online, look at this part. The inlet is here on this red side, and the wall is over here. Okay, the wall is here while the inlet is here, and there is some symmetry boundary condition, meaning to say whatever's on the top here is reflected on the bottom here. That's what the symmetry boundary condition does. It's like a reflective or something like that, reflecting boundary condition. But what it's saying is that you don't put your inlet here next to the wall, because that's not like truly so-called free stream. Because at the corner, the bottom left hand side, here's your inlet and here is your no slip. So there's a no slip. So at this corner there will be kind of a conflict here. The velocity, if you have this one little box here, it will say that the no slip condition will detect that hey, the velocity here should be 0. But this inlet boundary condition will say, hey, the velocity here is supposed to be 1. So putting these two so close together may cause some problems. So that's why you gotta maybe they give it some kind of a runway before actually meeting this the flat plate that we're talking about. So if you want to modify, let's say our flat plate, we might want to add a little bit of a space here, and we'll shift our inlet further left, and here we'll have a symmetry or zero gradient, kind of a boundary condition, and here we also have zero gradient. So that's one thing about our geometry that we want to try and implement to see if this problem I was talking about, having the two boundary conditions so close to each other without this runway I was talking about here, to see whether that's causing the problem. And if you notice, the mesh here isn't exactly uniform throughout. The mesh size here is significantly bigger than, say, the mesh size here. Now, why would you want to do that? Well, most of the action happening in the boundary layer is usually along here, right? And over here, there's a very, there are lots of interesting things happening down there. Whereas over here, things are more, predictable and not as boring. Well, the correct technical term is to say that this is a very non-linear velocity profile region. That means the velocity can change very abruptly over here. However, over here, the velocity changes are more gentle, more linear, so to speak. They are like the how to say, what's this thing? Let's put partial u, partial y, and partial u, partial x, of course. Okay, it's very difficult to write. Okay, so the velocity gradients here, over here, in this orange circle, they're not as abrupt as, let's say, here in this blue circle. So all the detail you kind of want to capture is in this region, okay, along the bottom. So, well, you don't want to waste a computational, time trying to simulate this rather boring region, and instead you want to spend more computer simulation, more computing time to simulate this region down here. Okay, these regions close to the plate. These are where the most abrupt changes in velocity are. Okay, so abrupt changes, maybe mesh. So let me stretch that out. Abrupt changes demand a more fine mesh. So you want to get your mesh refined where the abrupt changes are. That's the logic behind it. Okay, so how are we going to change our geometry file like so? Where we first extend this boundary here, we duplicate whatever we have on this right hand side, and we try and duplicate it here, and then we'll try and, after that, of course, we have a mesh like so. In these blue areas, we want it more refined, just like what we see here. How are we going to do that? So in the next few videos, we're going to explore some of the important things inside the blockMeshDict file, which will help us to determine the mesh grading. This is called mesh grading. That means the mesh size actually changes as we proceed along the x-axis. How can we imitate this or copy this inside our OpenFOAM file? And of course, we want to change our geometry a bit by adding this new block over here. Okay, so I'll break it into two parts. So part 1. Yeah, so part 1 is to write a new segment of the blockMeshDict file. So we want to extend our blockMeshDict, extend our blocks so that we have two parts similar to what we have here. So that we have this on the left side and this on the right side. And after that, part 2, we want to introduce mesh grading. So again, mesh grading is where you see the mesh size gradually start to change as we progress along the x direction and we progress along the y direction. So the mesh size actually changes. So this is called mesh grading, and it helps us to save computational time. Okay, so and if, of course, if that doesn't work, we'll try and find out what's actually wrong with our system. So we'll test this out. We'll want to test this out and go from there. That's the game plan anyway. So first things is first. How do we write a new blockMeshDict file? If we see our flat plate, of course, and our CD system. Okay, if we see our blockMeshDict file, we notice that we only have one block, whereas the file that we want to write has two or more blocks. So it has two blocks, right? And then how are we going to write out this new block? We have not learned anything about writing blocks yet, and it seems pretty complicated because you have to define coordinate by coordinate. But don't worry, we'll look at some example files and we'll head off from there. Alright, let's look at the cavity folder first. So I've already copied the cavity folder here into this cavity full. Okay, if you're not sure, I'll delete this. Okay, I'm just going to demonstrate. So I'm just going to delete this cavity full. I'm going to go to the tutorial folder. So you navigate to your own tutorials folder. I've just copied the tutorials folder here for convenience. I'm going to go to incompressible, and I'm going to go to OpenFOAM, and I'm going to copy this entire cavity file here. So cd cavity. So I'm going to copy this address. So you don't have to type pwd. If you can just copy it from here. It will basically give you the same thing. So now bring us back to this folder, and let's paste it here. So cpar, all this we're gonna type it as cavity full. That's all we need to do. I'm gonna shift it here so it doesn't block. Alright, so that's how I got my cavity full. Okay, so you have 3 files here. You can just do a simple or run script to help it help it get there. So these are all this is the entire OpenFOAM tutorial folder. Okay, so we want to move on to this one called cavity clip. Now you don't have to do an or run because all we are looking at is the blockMeshDict file. I'm just doing that to demonstrate that we can just do, it's a little extra step. You don't really need to do it if you don't want to. Okay, so we'll go to System and blockMeshDict, and let's look here. We have many vertices here, of course. Okay, all of these vertices, and we have 3 blocks. Now what does it look like in real life? What it actually looks like is this. So we'll go to the cavity tutorial OpenFOAM. Okay, Where is that? Well, yeah, we can go to the OpenFOAM v6. This is the other branch of OpenFOAM, but it's similar enough. We can actually just look at the same tutorial. So we'll go to find clipped. Okay, this is how we change the case geometry. So what happens to the original cavity file? Remember our blocks here. So they chop off the bottom right hand corner of the box. Okay, so we'll actually have 3 blocks here. Okay, I'm going to copy the image and I'll paste it here. So the 3 blocks in question are here. Excuse me. 1, the top left, and the top right. And then the bottom right, there's nothing. So there are 3 blocks. 1. Okay, so 1 block, 2 blocks, and 3 blocks here. Okay, so that's how the cavity clip file is working. So this is actually quite good for what we want to do. Now, how are we going to see this cavity file? Well, all the vertices are placed here. These are the corners of the blocks that we are putting into OpenFOAM. And each block will consist of 8 points. So this is 1 block, this is 2 blocks, and this is the 3rd block. Now, understandably, it's very, very, very hard for us to visualize what the blocks are going to look like just by looking at this file. So we'll need something a little more, a lot more visual to help us to see. Okay? And of course, and if we look at how the faces are written, the numbers are shown here. Okay? So there is a specific order in which we must write the blocks. 1, we must write the blocks in a particular order of the numbers, and we must write the faces also in a particular order. Now that sounds very intimidating, and it can get very confusing at first, but we'll go through it step by step, so don't worry too much. Okay, so first thing first, we'll want the coordinates of this. We want to plot this in 3D to visualize what our block looks like, and then we can see which point all of these are actually talking about. Okay, so let's go to Excel. Excel is our best friend. Okay, so anyway, this is a file I've actually developed to help write the geometry. I'll teach you how to write one in the coming videos. Write your own. But first, we want to paste it. We're gonna paste our vertices here. So I'm gonna paste it here. Okay, obviously you don't want it to be like this. You want it to be in a form where you have 0 here, 1 in each column, basically. Okay, so how are we going to do that? So I'm going to Control Z to undo. I'm going to paste again, press the Control button, text import wizard. Yeah, so text import wizard and put fixed width. After you use fixed width, okay, fields are aligned by columns with spaces within each field. Okay, so we are going to separate it out like so. Okay, let's see delimited. Yeah, delimited does just as well. You see, it separates out by the space. And if you can use the brackets as well. Okay, so both actually work. Of course, ideally we want the right hand side to be taken out as well, the right hand side brackets, but that's very easy to solve. As long as we have this, it's good enough. Okay. So, yeah, we'll just leave it as that, and we can do it like so, finish it up, and see. Our text is imported as in this form. Okay, so the next thing you want to do is to remove these brackets, because now we're going to paste them into a plotting software, which you can easily find online. So for this, of course, we can use the left file. Okay, left, and I want the first. Okay, so the formula goes like this. You take left, that means we'll pick out the first from the counting from the left, the first character. So we only want one character, so we'll just put 1. So we highlight the cell that we want to alter, then we put 1 there to say that we only want the first character. So that is 0. Do it all the way down. Now we can do something similar for the bottom. Only thing is that, okay, this will be the left, the first character from the left of this text here. Now obviously we want more than 1. Okay, we want more than 1 character. We want 3, because 0, the decimal point, and 1, these are 3 characters. So we'll do that. 3. There you go. We'll paste it here. The values X, Y, and Z. Okay, so we'll want to convert this to numbers. Okay, we'll have the number value of this, so you can tell which is a number by which side of the text it's aligned. So let's say a 0. If we type in 0, it will align to the right. That tells us it's a number. That's the usual default for Excel. And if we put a 0 and a apostrophe, it will be like so. Yeah, apostrophe 0, it will become a text format. So you want to change to the number format. All we have to do is this: number value, then select the cell you want to convert, close it, copy and paste wherever you want to, so that it will do so, and then you can take the whole file, copy and paste here. Okay, now just very quickly before I end this video, I want to bring you to this website called plot.ly. .ly 3D scatter. Okay, there should be an online plotter. Okay, let's see where it is. Okay, where is it? Where is it? There you go. Plot.ly create. So you let it load. Okay. So we will have we want to have analysis or trace. Okay, so we'll just select trace, go for a 3D scatter plot, then we can visualize our data in 3D. So copy the data you have, paste it here. Very simple. Then let the scatter plot do it for you. So we don't really need a spacebar, but whatever, okay? So A column A will be X coordinate, column B will be Y coordinate, column C will be Z coordinate. And very quickly, this plot ly will help us to visualize what the geometry will look like, or at least for very simple points. Now I'm going to stop here and we're going to continue. I want to continue this in the next video. Thanks for watching. I'll see you guys next time. Bye bye.